We are counting down the 6 most destructive driving habits quietly ruining Chevy engines. From hidden morning mistakes to habits that escalate wear with every mile, each entry reveals how ordinary choices lead to surprising, costly damage, often without owners realizing it. Some behaviors may seem harmless, but their long-term effects are anything but subtle. Which habit takes the top spot? Let us begin our countdown at number 6. Accelerating a Chevy engine before it is warmed up is a habit that quietly shaves years off its life. On a cold start, engine oil is thick, up to 5 times thicker at -10 degrees Celsius than when hot. This heavy oil takes time to move through tiny passages and coat every bearing, piston, and ring. For the first 20 to 30 seconds, critical parts can scrape directly against each other since the protective oil film has not fully formed. That is when metal-to-metal contact does its worst, causing damage over time. Owners might later notice blue or white smoke from the exhaust, especially after repeated cold pulls, or find themselves topping up oil more often as the rings and bearings wear down. Some Chevys even show a rough idle or a brief rattle on those chilly mornings. The fix is simple but essential. Keep your foot light on the throttle until the temperature gauge starts to move. Chevrolet owners' manuals recommend avoiding hard acceleration until the engine reaches normal operating temperature. By giving your Chevy 1 minute to circulate oil and build pressure, you protect the engine from the kind of damage that is invisible until it is too late. Letting a Chevy engine idle for several minutes on a cold morning might sound like the safest way to warm it up, but this old habit can quietly do more harm than good. Modern fuel injection systems don't need extended idling. 10 to 30 seconds is enough for the idle to stabilize. After that, driving gently warms the oil and engine parts 4 times faster than sitting in the driveway. The problem with long idling isn't just wasted time or fuel. While the engine sits cold, unburned gasoline seeps past the piston rings and mixes with the oil. Even 5 minutes of idling can push fuel dilution above 2%, weakening the oil's protective layer. That thin oil can't shield moving parts as designed. Meanwhile, in direct injection engines like Chevy's Equinox 1.5T, idling accelerates carbon buildup on the intake valves. These sticky deposits block airflow and raise the chance of a cold start misfire by 30% over time. Drivers often notice a rough, idle, sluggish response, or a check engine light after months of this routine. The best approach is simple. Start the engine, wait for a smooth idle, then drive off gently. This gets everything up to temperature quickly, burns away contaminants, and keeps carbon at bay. For modern Chevys, a short, idle, and gentle driving protect the engine far better than a long warm-up ever could. Lugging the engine, forcing your Chevy to accelerate or climb in too high a gear, creates a kind of hidden strain that few drivers notice until it is too late. When the tachometer dips below 1,700 revolutions per minute under load, especially going uphill or towing, the engine struggles to move the car without enough rotational speed. Instead of spinning freely, the crankshaft and main bearings are slammed with extra pressure. In fact, bearing load at 1,500 revolutions per minute during a hard pull can double compared to cruising in the correct gear. In modern turbocharged and direct injection Chevys, like the Equinox 1.5T, this low RPM stress is even riskier. The engine's knock sensors can pick up 5 times as many knock events when lugging under load, raising the chance of detonation and piston damage. Here's a quick tech break. Lugging happens when cylinder pressure spikes before the engine is spinning fast enough to spread out the force. That means each combustion event hits the bearings and connecting rods harder, overwhelming the oil film that is supposed to protect them. Spotting lugging is simple. If the engine sounds rough or rattles under acceleration, and the tachometer is stuck below 2,000 revolutions per minute. While climbing or towing, you are in the danger zone. The fix is straightforward: downshift early, or let the automatic transmission pick a lower gear, keeping revolutions per minute in the engine's torque band, usually between 2,000 and 4,000 revolutions per minute for most Chevys. Easing off the throttle when the engine feels bogged down also helps. By staying out of the lugging zone, you protect your bearings, reduce knock, and extend the life of your Chevy's heart. Leaving a Chevy engine running while parked or waiting in traffic may seem harmless, but the damage builds in silence. Once the engine has stabilized after startup, any idling beyond 30 seconds does more harm than good. Inside the crankcase, oil starts to break down as the engine sits. An incomplete combustion at low temperatures triggers a slow chemical reaction. After just 15 minutes of continuous idling, sludge begins to form. Thick, sticky deposits that cling to bearings and block narrow oil passages. Varnish coats the inside of the engine, making future oil changes less effective and raising the risk of costly repairs. Catalytic converters also suffer. Chronic idlers can see converter efficiency drop by nearly 25%, contaminating the emission system and threatening to trigger a check engine light. According to ASE-certified master technicians, idling-related failures are one of the most common warranty complaints on late-model Chevrolets, especially in cities and cold climates. A GM dealership service advisor says they see more sludged engines from excessive idling than almost any other habit. The fix is straightforward: limit idle time to 30 seconds whenever possible. If you are parked or stuck for longer, shut the engine off. In cold regions, plug in a block heater to warm the engine before starting. These small changes keep oil flowing clean, protect emissions equipment, and help your Chevy last well beyond the warranty period. Selecting the wrong gear during acceleration puts intense strain on a Chevy's engine and drivetrain. Dropping into second gear at 6,000 revolutions per minute pushes the valve train beyond its safe operating range. Valve springs, designed for a specific engine speed, cannot keep up at those speeds. The result is valve surge. Valves bounce instead of closing cleanly, and rocker arms, lifters, and the camshaft face rapid wear. In some models, a hard shift at redline can exceed the valve spring's surge limit by 8%, setting the stage for early failure. Manual transmissions bring their own risks. Aggressive shifting and clutch slip under heavy throttle can spike clutch temperatures by 100 degrees Celsius in just 10 seconds. This heat breaks down friction material and can warp the pressure plate, leading to weak engagement or a burnt smell after spirited driving. Automatics are not immune. Holding a low gear in sport mode or using manual tap shift for engine braking increases torque converter load, raises transmission fluid temperatures, and thins protective films. Valve spring surge happens when the spring loses control of the valve's motion at high engine speed, causing the valve to float or bounce. Symptoms include sudden power loss at high engine speed, ticking noises from the top end, a soft clutch pedal, or a burning odor. Transmission slip and delayed engagement signal trouble for both manuals and automatics. The owner's manual shift table is the best guide. Shift before redline, avoid low gear downshifts at speed, and let the transmission logic do its job. Smooth, timely shifts protect the entire drivetrain. Aggressive driving pushes every part of a Chevy engine and transmission to their limits. Hard launches, repeated full throttle bursts, and late braking do not just wear out tires and brakes, they set off a chain reaction deep inside the engine. Each surge of acceleration raises oil temperature fast. In just 90 seconds of spirited driving, oil temperature can climb by 40 degrees Celsius. As the oil heats up, its viscosity drops by nearly a third, thinning the protective film that separates moving metal parts. Bearings and piston rings, designed to ride on that thin layer, start to run dangerously close to metal on metal contact. This is the start of what mechanics call a thermal cascade. As oil thins, it can no longer cushion high loads, so friction and temperature keep climbing, starving critical bearings of lubrication. Here's a quick tech corner. Engine designers use a curve called viscosity versus temperature to match oil to the engine's needs. When oil gets too hot, it loses its ability to form a strong film. For every 10 degrees Celsius over the recommended range, wear rates can double as the oil's strength drops. Consequences show up at repair shops first. One Chevrolet owner brought in a Camaro SS at 85,000 miles, less than half the expected lifespan. The invoice listed a full engine and transmission overhaul. The cause was years of hard launches and full throttle pulls. The shop found scored bearings and a burnt transmission, classic signs of oil starvation and heat breakdown under high load. The fix is straightforward but takes discipline. Defensive driving, gentle acceleration, smooth braking, and anticipating traffic keep oil and transmission temperatures in check. Gradual throttle lets oil pressure keep up with demand, and smooth braking prevents heat soak in the transmission. For spirited drivers, short bursts are less damaging than sustained aggression. Regularly monitoring oil temperature and changing oil on schedule help too. Simple changes in driving style can add years to a Chevy's engine and transmission, save thousands in repairs, and keep the car on the road where it belongs. Across all 6 habits, one pattern stands out. Engine damage starts with small everyday choices, not rare failures. In Chevy's, longevity is not just about engineering, it is shaped by the driver. Every mile is a vote for your engine's future. How do your habits stack up? Share your thoughts below.